Doppler effect. Doppler effect in sound. Doppler effect in sound. The apparent change in frequency. The apparent change in frequency of sound wave. Apparent change in frequency of sound wave produced from a source due to relative motion, between the source and the listener, between the source of sound wave and the listener, is known as Doppler effect in sound. Is known as Doppler effect in sound. The apparent frequency heard by the listener, the apparent frequency of sound wave heard by the listener, the apparent frequency of sound wave heard by the listener, which is in relative motion, heard by a listener which is in a relative motion with the source of sound wave is given by, which is in a relative motion with the source of sound wave is given by nu prime equal v minus bl cos theta divided by v minus bs cos phi, bracket close, into nu. Nu prime equal v minus bl cos theta divided by v minus bs cos phi into nu. That is the apparent frequency of sound wave heard by the listener, where nu is the actual frequency or true frequency of sound wave produced from the source, produced by the source, which is denoted by S, and the source is moving. Source is moving with a velocity Vs, at an angle phi, with the direction of sound wave propagation, In the diagram, S is the source of sound wave which produces sound wave in all directions. S is the source, and from the source sound wave is traveling with a velocity v towards the listener. V is the velocity of sound wave, and the source moves in this direction with a velocity vs at an angle phi with the direction of sound wave propagation. Nu is the actual frequency and L is the listener of sound wave. This is the direction of sound wave propagation, and listener travels in this direction with a velocity VL at an angle theta with the direction of sound wave propagation, and nu prime is the apparent frequency heard by the listener. V is the velocity with which sound wave propagates in all directions. VL is the velocity of the listener. VL is the velocity of the listener which moves in a direction, at an angle phi with the direction of sound wave propagation. In the diagram, sound wave is traveling with propagates with velocity v towards the listener. Nu is the true frequency or actual frequency, and we assume that the source is traveling towards the listener, and listener is traveling with the velocity vl in the same direction as that of the source. That means source and listener are moving in the same direction. If the source S and the listener L move in the same direction, or move along the same straight line, that means in the same direction, then theta equal to 0 degree and phi equal to 0 degree, and nu prime equal v minus bl cos 0 degree divided by v minus bs cos 0 degree into nu. So finally we get nu prime as equal V minus VL divided by V minus Vs into nu. So this is the apparent frequency of sound wave heard by the listener, provided both sound and listener are moving in the same direction. Apparent frequency of sound wave heard by listener, where V is the velocity of sound wave which travels from the source to listener. Again, we can consider a diagram. Source S be the source, and from source sound wave travels with a velocity v in all directions. So in all directions, sound wave propagates with a velocity v. V is the velocity of sound wave. A sound wave can propagate in all directions, and L is the listener. In this case, L is the listener, and we should consider the velocity v of sound wave which travels from source to listener, and source is moving in the same direction of sound wave propagation towards the listener. That means Vs is parallel to V, and VL is also parallel to V. In this case, nu is the actual frequency or true frequency of sound wave produced from the source, and nu prime is the apparent frequency. Nu prime is the apparent frequency of sound wave heard by the listener. Therefore, nu prime equal V minus VL divided by V minus Vs into nu. That is apparent frequency of sound wave. Apparent frequency of sound wave heard by the listener, provided source and listener both are moving in the same direction.